So solid iron 3 oxide reacts with carbon monoxide gas to produce solid iron metal and gaseous carbon dioxide. We're going to have to translate this equation. So iron 3 oxide. Iron 3 means it's Fe with a +3 charge, and oxide is O with a -2 charge. The +3 and -2 will switch or crisscross or flip-flop. This means I need 2 irons, and this means I need 3 oxides. Plus, carbon monoxide is carbon and oxygen, and there's 1 carbon and 1 oxygen. We're going to produce solid iron, and carbon dioxide is CO2. Now we have to balance the equation. We have 2 irons on the left, so we'll need 2 irons on the right. This is where things will get a little bit tricky. We have 3 plus 1 is 4 oxygens on the left, so 2 times 2 is 4 oxygens on the right. But this means I need to put a 2 in front of the carbon on the left side, and you'll notice that throws off our oxygens. Now we have 3, 4, 5 oxygens on the left, but 4 on the right. So that's going to be kind of weird because we have 5 on the left and 4 on the right. A trick would be to change this coefficient to a 3, which changes this one to a 3. So I'm basically moving the carbon coefficient up to 3. And now look what that's done for our oxygens. 3 on the left plus 3 more is 6 total oxygens on the left, and now we have 3 times 2 is 6 oxygens on the right. So we have a 1, 3, 2, 3 ratio across this equation. So now I'm going to write the molar masses of each of these right above them. This is 159.7. This is 28.01. This is 55.85. And this is 44.01. And these are the molar masses that you acquire from the periodic table. Okay, so we are given the amount of iron 3 oxide is 171.0 grams, and we're also told the amount of carbon monoxide is 101.7 grams. And the question is asking, what are the total masses of gases that will be present after this reaction is completed? And the thing that we need to keep in mind is this is in the solid phase, this is a gas, this is a solid, and this is a gas. So really, I want to know how much carbon dioxide is produced, and I need to combine that with however much carbon monoxide is left over. Now, we might use all of the carbon monoxide, in which case this will be the only gas present. But if we have excess carbon monoxide, then we'll have both CO and CO2 present as products. So we need to find out what our limiting reactant is first. So we're going to do 2 stoich problems. One will stoich from the iron 3 oxide to carbon dioxide, and then we'll stoich from carbon monoxide to carbon dioxide. So we'll start with this one, 171.0 grams of Fe2O3. The molar mass is 159.7 grams of Fe2O3, which equals 1 mole. And then we can do our mole-to-mole ratio between Fe2O3 and carbon dioxide. There is 1 mole of iron 3 oxide to 3 moles of carbon dioxide, and then we'll convert carbon dioxide from moles to grams using the molar mass. If I type in 171 divided by 159.7 times 3 times 44.01, I get 141.37 grams of carbon dioxide. So that's how much carbon dioxide I produced based on this given amount of iron 3 oxide. Now we'll figure out, using our carbon monoxide, 101.7 grams of carbon monoxide over 1. 28.01 grams of carbon monoxide equals a mole. We'll do our mole-to-mole ratio between carbon monoxide and carbon dioxide. It's 3 to 3. And then convert carbon dioxide to grams. When I type in 101.7 divided by 28.01 times 3 divided by 3 cancel, and then times 44.01, we get 159.79 grams of carbon dioxide. So between these two, the smaller of the two is going to be the true theoretical yield, which is this 141.37 grams, which means this is based on the excess and is not a possible yield. So this means that the iron 3 oxide is our limiting reactant, which officially makes my carbon monoxide the excess. So we do have leftovers of this 101.7 grams. And so what I need to know now is how many grams of carbon monoxide are we going to consume with this iron 3 oxide. So now I'm going to do a Stoic problem from this given and figure out how much carbon monoxide will it consume. So 171.0 grams of iron oxide. Use the molar mass from the periodic table. It's 1 mole of iron oxide to 3 moles of carbon monoxide, and then we'll convert from moles to grams from the periodic table. So 171 divided by 159.7 times 3 times 28.01 is equal to 89.98 grams of carbon monoxide consumed. We have this amount here, 101.7 grams to start. So if I use up 89.98 of the 101.7, then I will have left over 11.72 grams of carbon monoxide. The final answer is asking for the combined total of gases. So I will take 141.37 grams of carbon dioxide plus the 11.72 grams of carbon monoxide, and that gives me a total of 153.09 grams of gases total, which is letter